Dear friends, once again on the same day, just after half an hour, we are meeting uh, because, as I told you, total number of 150 videos are in my mind. And I don't know how many videos I've done. I think I might have done some 30 by now. So yet 5 times that is in my mind. And the material of at least coming 20 videos is ready. It's just a question of my speaking and uploading it on YouTube. So speaking for half an hour, and after speaking I have to check my own video because it should, I mean, there should not be uh, any any such a mistake which I can see by my eyes, and then everybody will say, everybody in the world will see. So that I have to delete. So I have to check that whole video. So if I have to make the video within half an hour, the another half an hour for checking, and then sending it for publication in the YouTube. So the complete process takes a lot of time. And if those 150 videos, if I want to cover within 75 days, within 2 or 2.5 months, I have to run at a very high pace, which I'm trying to do. And in that process right now, we are running through experiments. And that is my idea that once we pass through a topic theoretically, say we have passed through a topic theoretically of overcurrent relays. Complete theory of overcurrent relays we have learned in YouTube videos. Then I have taken up all practicals, all possible practicals on overcurrent protection. And then such simple experiments in power systems. Now we will be taking up distance protection, and then we will take up line differential protection, and then we will take up generator protection, and then there will be some experiments on generator protection which we have rigged up in laboratory. So how generator can be understood in laboratory, that also we would like to see. How transformer can be understood, can be seen theoretically, I mean practically, by taking readings and by understanding ourselves, that we would want to do. So, I mean, aligning all these things takes a lot of time and takes a lot of labor too, lot of efforts too. But those efforts I'm making for all my loving friends, so that you learn power system protection. That is the only goal, right? No doubt. The another goal is to make our organization adapt me, our product of the business adapt me, to make it uh, popular, to make it known to every corner of the world. That is also a wish out of that, right? No doubt. But with both wishes line in line, I am right now passing through the different experiments. I think this and after one more, that is floating neutral. Those two experiments, the experimental part will be complete and we will enter into theory once again. We have seen transmission line protection by overcurrent relays, and then now we are going to see transmission line protection by distance relays. So for distance relays, there will be at least 12 to 13 videos to teach, I mean to completely teach the distance protection. Anyway, right now we are learning the MCB characteristic, how to plot the MCB characteristics. So first thing is we must understand MCB. MCB means miniature circuit breaker, which is used in household applications also. You see, in earlier days, people were using fuse. So what happens that due to overload, if the fuse blows off, then you have to remove that fuse, right? And you have to replace the fuse by another fuse element, which layman cannot do. Layman means a person in the house, everybody, all persons in the house can do. Usually, a wireman can do it, so they will call wireman, no doubt. But if I have to do, I cannot do. I have to do means I am an electrical engineer, I can do anything, but what by I mean a common man. Common man cannot do. Whereas MCB common man also can do because he is making the light on every day for making his room light on, for making fan on, he's making the switch on. MCB is a simple similar switch. You make it on and it is on. But it does many other functions. Very important function of miniature circuit breaker is overload. When your equipment that is being protected is overloaded, then MCB will protect it by getting tripped. Before the equipment is damaged, the MCB will trip. So you see, in this one should understand the very important fundamental of protection, that the cost of protective equipment should not be more than 5 to 10% of cost of equipment. MCB is available in some 300, 400 rupees. So if your equipment, your wiring is of 4,000, 5,000 rupees, which it is, and therefore MCB is all right. So here we can use MCB. When we go for transmission lines and breakers and all, we cannot go for MCB. Then we have to go for versatile protection. But MCB is a simple device. It protects against overload because that means it works on thermal overload principle. Because it is heated, some element is getting heated, and that heated element works to trip the breaker, to trip the miniature circuit breaker. That is for over currents. That is, say I have got a 2 ampere load, then 3 ampere, 4 ampere, 5 ampere, 6 ampere are overloads. But if the current is equal to 10 ampere, 5 times, 10 times the current passes, then it is not overload, it is fault. There is some fault has occurred. At that time, there will be heavy damage in your housing, in your house wires. Not only in house wire, MCB is used in commercial buildings, MCB is used in industries, MCB is used for motor protection, many things. But small motors, not big motors, right? Because for big motors, the versatile protection is used. So when we are using MCB, when large current passes, 10 times current passes, there is another arrangement of instantaneous trip, and MCB will instantaneously trip. Instantaneously means within very short time. Actually, it gives a cutoff characteristic like fuse. It won't reach even peak of the current. 2 ampere MCB can safely interrupt 6 kiloampere of current or 9 kiloampere of current. So actually it will not allow it to reach to 9 kiloampere. Before it will isolate, and then the relevant arc that is occurs, that arc has to be quenched. So arc quenching arrangement also has to be kept in MCB. So this is all MCB about, that one has to understand about MCB. And at different currents, within what time MCB trips, that we would want to study. It is very obvious that if the current is low, my device is taking 2 ampere, and if 2 ampere is passing, it is taking normal current. But if 4 ampere is passing, and it is taking more current, right? But it is not so much more that it has to be tripped immediately. because 4 ampere can be withstood for 5 minutes. So I should wait for 3 or 4 minutes. I should not trip immediately, because it is quite possible that, that 4 ampere of current may vanish within seconds. Then why should I unnecessarily trip? That means MCB has to give you inverse curve. Inverse curve means the time of operation of MCB should be inversely proportional to current passing through it. Right? So this is an MCB. Having known this much, we enter into the experiment. Motivation is that miniature circuit breaker has replaced fuses at most of the places. Probably you will not find fuses anywhere now, and therefore MCB should be learnt by all electrical engineers at least, right? If not everybody, it should be learnt by electrical engineers. The objective is to plot the current time characteristic of MCB, right? MCB is a low voltage device. Up to 440 volt it is available. Current ranges up to which the MCB is available is 0.5 ampere to 40 ampere. That is MCB rated for as low current as 0.5 ampere is available, and up to 40 ampere full rated current. That is full time, 100%. 24 hours and 365 days, you can pass 40 amperes through that. But for currents, if you want to pass some 2000 ampere, 3000 ampere, then MCB cannot be used. There people are using MCCBs, molded cage circuit breakers. The principle of both MCB and MCCB is more or less the same. Only the range is different. The current range is different. Fuses. What is the problem with the fuses? That when it melts, it has to be replaced. And 5 ampere fuse is there, and you have to replace only 5 ampere fuse. But an unknown, person who is not fully knowing things, who is not skilled, may replace 10 ampere fuse. Then next time when fault occurs, rather than fuse protecting your fan or your equipment or your household equipment, that household equipment will protect the fuse. It will be reverse. So that should not be the case, right? Sometimes, so often I've seen that in field, line staff are using cables instead of fuses, so that they will not to every now and then go to replace the fuses. Equipment will burn. Who is worried about it, you see? સંપત્તિ જે છે એ કોઈ એક ઘરમાં તમારી, if your own things are under danger, you are worried, you will complain 15 times. But if it is the of people, everybody, then nobody is worried. A thing which is of everybody is of nobody. Nobody is worried. In MCB, this is not possible. In MCCB, this is not possible because it is a sealed device. So it operates exactly according to its characteristic. MCBs are available in single pole version, 2-pole version, 3-pole version, and 4-pole version. All versions they are available. Now for carrying out an experiment, you see that at what current, at what time it trips. We have devised a circuit, and we have to connect the circuit according to it. And in that you will see that some dummy terminals are there. These dummy terminals are coming because you see, we had the space of some 15 tables in our laboratory, and we have designed 60 experiments in one laboratory. So 60 experiments in the area of 15 tables was just impossible. Therefore, one table, there were 4 experiments, 3 experiments. And therefore, you see, we had to identify the terminals for different experiments. Therefore, this word dummy terminal is coming. Otherwise, there is nothing like dummy terminal. the circuit details, if you want to see, is like this. That live and neutral is given to the, I mean, going to the contactor. Contactor coil can be made on and off by a switch, right? By switch, you make the contactor coil on and off. It should become off automatically also, but then contactor will not become off automatically. It will be MCB will become off. Then in series, you can see that there is an MCB. In series, there is an MCB. And in parallel to MCB, we are keeping a 15 ampere switch so that while we are adjusting the current, MCB does not trip. We will adjust the current exactly as what we like. During that time, MCB will not trip because current is not passing through that. But once the MCB, I mean, once we are sure that we have passed so much of current, you see, then we will make this switch off and MCB on, and then current will start passing. And after predetermined time, the MCB will trip. Then what we have done? Then across the supply, we have got an auxiliary relay, which is a 230-volt relay. So it is getting 230-volt supply. Its NO contact closes and it starts the timer, right? We have got an emitter, portable 025, 0210, 0220, because we want to take reading in a large range. We want to start taking reading from 0.5 to a large range. So often we would want to test not only 2 ampere MCB, we would want to test 4 ampere MCB or 5 ampere MCB or 20 ampere MCB. Therefore, we need different emitters. So the emitters are there. Then there is a load, lamp load is there, right? And NC contact of auxiliary wire. Why NC contact? Because when MCB trips, the auxiliary relay de-energizes and its NC contact will stop the timer. So you will know the time of operation of MCB. So pass the current, note down the current, note down the time, take different readings and plot the characteristic. Actually, this much is the experiment. There is nothing more in the experiment. If I talk, this is the only, I mean, the experiment is complete. Temporary connection, once again it comes because we have multi experiments on single table. So certain temporary connections we are doing for one experiment, some another temporary connections for another experiment. Therefore, such words are coming. Then connect start and stop terminals of timer. Make MCB off and keep the shorting switch on, because now first we would want to adjust the current exactly what we want to pass. Make the contactor on by switch and then adjust the load current to 2 ampere. Our MCB is 2 ampere and we are adjusting the current to 2 ampere. We know that MCB should not operate. And that is what we would want to confirm. That we will wait for 5, 10 minutes, 15 minutes and we will see that MCB does not trip for 2 amperes. But now you try to understand, you see, that when you are passing 2 ampere through MCB for 15 minutes, 20 minutes, half an hour, 1 hour, 4 hours, or 1 day, because you see in industry you are passing for complete 365 hours and 24 days. Then you see, obviously, the parts inside the MCB, they are not at normal temperature. They are not at room temperature. Otherwise, they are at room temperature. The main device on which MCB is working is bimetal strip. Two different metals of which are having different coefficient of expansions of heat. That means when they are heated, they will be expanded separately. One will be expanded to 4 centimeter, another will be expanded to 4.4 centimeter. But they are welded together. So when they are expanded, they will have to bend. And bending of MCB, bending of bimetallic strip is used as a latch, to trip, as a mechanical latch to trip. So tripping mechanism is connected with bimetal strip. Now you see, bimetal strip is not straight when you pass 2 ampere for 2 days. It has bent, but it has not come up to the latching point, because when on one side the heat is generated because of 2 ampere I square RT, there is heat dissipated also. Heat generated is proportional to I square RT. That is, I is the current, that is square of the current. R is the resistance of the device, that is resistance of MCB parts, and T is the time for which the current is passed. But heat dissipated is proportional to TD raised to 4. TD means temperature differential. Temperature reached minus room temperature. Now, as you pass the current, the temperature goes on increasing. So that temperature minus room temperature differential will go on increasing, and heat dissipated is fourth power of that. Therefore, heat dissipates faster than it generates. Heat dissipation rate is faster than heat generation. So point will come when heat dissipation will be equal to heat generation. So now no more heat can be dissipated, no more heat can be generated, and the temperature established at that point is known as the equilibrium temperature. That is obviously not room temperature. Your room temperature is 30 degree, then you are passing 2 ampere full current for 2 days. The temperature which will not be 30 degree. It will be some 35, 40 or 45 degree. But I know that my MCB uh, insulation is going to be damaged, or my equipment is going to be damaged if the temperature reaches 60 degree. So I should see to it that it does not reach to 60 degree. But now try to understand that if you are starting the MCB fresh, it has to start temperature from 30 degree room temperature to 60, the damaging temperature. But if it is running for last 2 days, then it has to start from 45 degree or 50 degree to 60. So obviously, if the MCB is under hot condition, MCB is already under working condition, then time taken to trip MCB is less. And if it is not under working condition, you are starting fresh, then time taken will be large for the same overload. Overload current is the same. I am passing 4 ampere, both cases. Once, in one case 4 ampere from 0, but in another case 4 ampere from 2 ampere. So all MCBs invariably have two characteristics, and they are known as thermal withstand characteristic. That if so much current is passed for so much time, then the insulation will be damaged. So that characteristics are two, double characteristic. One is hot, another is cold. Hot characteristic always below cold characteristic. So one has to remember this thing when one is using MCB. This is very important, right? And because of that, you see, when you are doing any relay setting work, this is also very important. So we have bypassed the MCB just to adjust to appear. Then we make the MCB on and sorting switch off. Observe that MCB does not operate. It should not operate. Now make the sorting switch on again and MCB off. Adjust the load current to 4 ampere, double. Then we will go to 6 ampere. Then we will go to 8 ampere. So now we have gone to 4 ampere. Once again, make the contactor off. And make the sorting switch off and MCB on. So now when you make the contactor on, energize the timer. Okay, you should really keep the timer ready. Now when you switch on the contactor, the current will start passing through MCB and timer will start counting. And MCB will trip as per its characteristic. And when MCB trip, the timer will stop. So you know current is 4 ampere and time of operation also you have measured. So you have got one reading. Similarly, you have to take readings for 6 ampere, 8 ampere, 10 ampere, 12 ampere, etc. Right? But MCB will operate at some current instantaneously, say 12 ampere. then taking reading has no meaning, because instantaneously means you just make it on and off. Probably the timer will not be able to take the reading, because timer is not meant to read 30 milliseconds or 40 milliseconds. It is measuring some seconds or some minutes. So take reading only up to instantaneously, and then tabulate the results and plot the graph, right? So this is what you have to do. So this is what was our business, that we are using MCB, and then we plot the characteristic. I mean, a typical characteristic is like this. For 2 ampere, at 2 ampere it does not operate. Beyond 2 ampere, say at 4 ampere, some point is on some 45 second, it operates. At 6 ampere, it operates within 15 seconds. Like that, you got the inverse curve and you came to know that the MCB, and it works accordingly, exactly according to it is desired to work. My equipment is going to be damaged if the current is large, and it is going to be damaged faster. Therefore, my MCB also trips faster. And therefore, my MCB characteristic should be below, that is tripping characteristics should be below the thermal withstand curve of the equipment to be protected. Thermal withstand curve of the motor to be protected. That one has to remember, and that is how one has to engineer. You see, this is just a half an hour video. Complete engineering of MCB or complete engineering of such thermal devices is just not possible. It is a big subject. It is not a very small subject. Very few people know the engineering of the plant or engineering of any small thing also. So everything cannot be taken. But these things you should keep in mind. Then I just wanted to give you an idea of specifications, how the MCBs are specified. You have to specify whether you want 1-pole MCB, 2-pole, 3-pole, 4-pole, how many poles you want. Then you have to specify you want 240 volt rating or 4. Beyond 450 it is not available. Rated current 0.5 ampere to 63 ampere. You have to specify which current you want. Right? Because if your equipment is taking 1.6 ampere or 1.8 ampere, you have to take 2 ampere MCB. That is very obvious. Rated frequency in India is 50 hertz. Now, rated short time breaking capacity. That is what current it can break without being damaged. And this is known by duty cycle. This duty cycle in Indian standard, it is specified as B to MB to MB. B is break. That means when you will pass very high current. High current means short circuit current. For 2 ampere or 6 ampere MCB, I will be passing 3000 ampere of current. And because of that current, it will immediately break. Then you have to wait for 2 minutes. And then again make. And fault current is passing. Therefore, it will be immediately breaking. Then again wait for 2 minutes and then make break. So you let the MCB pass through this sequence. Then you take the MCB out and then check up for operation test. That means whether the MCB is capable of being on, off or not. It is becoming on or off or not. Then you have to see the temperature rise test. It has to pass the temperature rise test. Then you have to see that it passes the dielectric strength test, that nowhere the insulation has been damaged. If it passes through everything like this, then you can say that it has passed the short circuit rated short time breaking capacity test. This is just a talk. This is just what I am talking. I am talking and you are hearing. So my lips are working and your ears are working. But if it is your MCB, then your heartbeats will be double. My normal heartbeats are 60 or 62 or 65. it will be certainly 100 or 110 when my own MCB is being tested. And my dear friends, I tell you that I have designed an MCB and my design was tested in the laboratory. At that time, my heart rate was very fast. And when they passed 6000 ampere, then arc was there. That arc flew some 2 meters up. जो arc था, that arc was flying 2 meters up the MCB. So we were worried whether the MCB will pass or not. By God's grace, the MCB passed the complete braking test. But when it passed, we enjoyed. At night we enjoyed a good dinner. We took good dinner. We took party. And when we reached factory people also gave us party because the MCB has cleared the test. Government laboratory has given the certificate. So now we can sell in the market, right? So any test for that matter, any test that you are reading, that is not just a test. If it is your MCB, something like that, you see, it is written in the paper that somebody was passing on the road and his 10 lakhs rupees were looted. એના ખિસ્સામાંથી 2 લાખ રૂપિયા કોક 10 લાખ રૂપિયા કોક ચોરી ગયું. Somebody has done the theft. Then it is a news. But if it is done from my pocket, then probably I'll be in the hospital. You see. So you have to understand the device like this. So the day you will start understanding the device, any electrical device, any testing, etc., like this, you will be able to understand it fully, right? Tripping factor, that is the ratio of minimum value of overcurrent at which the MCB will trip to the current rating. Usually it is 1.3. That means 2 ampere MCB will strip at 1.3 times 2, not before that. That is the general understanding. MCBs are available in duty M1, M1.5, M2, like that. What is the meaning of M1? It is designed for prospective current 1000 ampere, 1 kiloampere. 1.5 means 1.5 kiloampere and 9 means 9 kiloampere. And for each current, what should be the power factor of the test circuit? And to maintain a particular power factor of the test circuit is also very difficult because you have to break the current when the angle between voltage and current phi and cos phi accordingly is this much. So that point on wave switching arrangement also itself is very costly, right? So through all these things you have to pass, and then only you will understand that small thing MCB, which probably we are not noticing also, what important it is. Overload trip is generally based on bimetallic trip, as we have told, right? But at what current it should trip instantaneously? So if you are using the MCB for domestic applications, it should trip somewhere between 3 to 4 times the rated current. That means if I'm buying 2 ampere MCB, 2 into 3, 6 or 8 amperes, it will trip instantaneously. But if I'm buying an MCB for motor application, where 6 times the rated current is the starting current, and it is going to pass for 7 seconds. So MCB should not trip instantaneously before 6 to 8 times the rated current. Its duty is different. Its requirement is different. You see, its type is different. Therefore, MCB's type B, C, and D. B is for domestic applications, C is for motor application, D is for applications where you are having devices which take a very high surge current, some 8 or 10 times the surge current. So these things are there. You have to test the MCB, test like IR test, that is insulation resistance test. You are doing by Megger, high voltage test. What is the method of this testing? That is written in IS. And if you do this test one by one, you will understand that how much time you take for MCB. For one MCB, practically you will take at least 2 or 3 days to learn. Right? High voltage test means both the terminals you have to short. Between both the terminals and the earth, you have to apply 2.5 kV, 2500 volt, and insulation should not be damaged. 2500 volts only for 1 minute. That is for 1 minute. Tripping test you have to do. Short circuit current withstand test you have to do. So breaking current test you have to do. So all these tests are very important. I am just passing through this within this short duration of time to talk about each and everything is not sufficient. You see, so if you are interested in all these things, you have to contact me someday. Otherwise, it is not possible to talk about these things immediately in such a short video. Choice of MCB is also a subject. That means for given motor or given equipment, which MCB you will choose. That is also a very important subject. Such topics are not taught in engineering institutes. That is our fate. We are not teaching so many things in engineering institutes, and therefore students are knowing only shallow. They are not learning full. And so to say, I should agree that I am also not teaching fully, because for teaching fully I need much more time. I need some 3 to 4 hours minimum, and I am talking within half an hour. So with this friend, the talk ends. Time for reading a sentence. The real question is not whether life exists after death. हाँ लोग बात कर रहे हैं कि जन्म के बाद मृत्यु है कि नहीं. Whether is there punarjanma or not? Is there rebirth or not? Some religions like Christianity, they are not believing in Muslim, Islam, they are not believing in rebirth. Person does not burn once he dies. Hindus are believing in rebirth. You are burning, you are taking birth again. Also says that that is not very important question whether you are there is death, there is life after that or not. Whether your birth is again you are taking place or not. The real question is whether you are alive before death. We are dead even when we are alive, because we are not studying with full sincerity. We are not studying with full things. I am passing through the road from my house to college, and during my passage I am seeing 5 distribution transformers, but I am not looking at any one of them. As an electrical engineer, I don't feel like looking at electrical things. I am dead, मरा हुआ हूं, मेरी पल्स चल नहीं रही. वैसे I am just living like that for enjoyment. I don't feel like learning from outside area. Area around you is full of electrical engineering if you are electrical engineer. It is full of computer engineering if you are computer engineer. It is full of mechanical engineering if you are mechanical engineer. But we are dead. We are not alive. So real question is whether you are alive before death. That is important. So with that, I remember adapt me. I cannot forget adapt me. So my last slide is always adapt me. Adapt me gives me a chance to speak to you. Adapt me gives me a chance to see you all. Adapt me gives me chance to teach you all. And adapt me gives you also chance to learn all these things at no cost, because you are learning on video. Therefore, thank adapt me, and I thank you all. I should not say good day. I should say good night, because it is, I think, 10:30. So good night, everybody. Don't forget adapt me. Don't forget appraise.